How are you feeling today? What your pointing is. So I've got a choice of some things that we could do today. We could look at a kind of maths. It's a special type of diagram. So we could do that, look at a diagram. We could carry on with some Macbeth. We were reading that, aren't we? Yeah. Or we could help some new people starting RPM by showing them how to create a simple lesson. And I've just created a simple one on owls. Or we could do something else. So we could do maths, Macbeth, something on owls, or something else. Which one would you choose? Or you want the maths? There we go. So I prepared something out of this book. We'll just have a little look at the book again. I'll show you what it's called. Let's just look at this book. It's called How to Free Your Inner Mathematician. Oh, and it's called Notes on Mathematics and Life. Oh, very interesting. So we've done one of the lessons from here already, which was the one that we did. We did the one which was, oh yes, the one which was that we looked at cicadas and prime number cycles, remember? So this next one is, oh, I've missed a letter out there. This next one is Voronoi diagrams. Oh, let's write that. V-O-R-O-N-O-I. Voronoi diagrams. Just for practice, let's see how well your hands are working today. We're going to spell Voronoi. V-O-R-O-N-O-I. And to make the oi sound, we need an I on the end. Touch I. I. Voronoi diagrams, or Voronoi diagrams. So first of all, we're going to think about how a tree grows. So on a tree, obviously you've got the branch, not the branch. Chris, I can't even think about the trunk. You've got the trunk. There's the ground. There's the trunk. And then you've got the branches that grow outwards like that. And they'll just keep growing out and taking in the light. So that would be a tree that kind of spreads out at the top a bit like an umbrella. Let's just label it. So, first of all, where would the trunk be? Touch it on the picture. Show me the tree trunk. There. And where would the branch be? Show me a branch. There. Good. So let's have a look and see how well your hands are working. Let's do a T for trunk. Let's see if you can write T. So T is just down and across. Down and across. Down. Oh, very nice. And across. Go on. Oh, do you know what? That's so nice. Let's try making it into the word trunk. T. Then for the R, you try it. Down. So down and round for the R. Down and round. Very nice. Now the U, like that. Down and back up again. T, R. So the U, I'll start you off there. down and back up. Very nice. And then the N, we're going to go down, up, round, down, up, round, down, up, round. Lovely. T-R-U-N, and then the K is down, and then we're going to do a line and a line. Down, line, line. So we're going to go down and then line and line. Just keep tight hold, keep tight hold. I'll reposition. Oh, there you are, we're going to do it. We're just doing those little lines to make the K. K. Oh, look at that. And another line down, I'll help. Trunk. Very nice labelling. So I'll draw an arrow. There. That's the trunk. Lovely. I like that picture. Okay, so that's one tree. Now, what happens when another tree grows next to it? Let's imagine that we've got another tree growing here. So I'm going to draw the trunk. I mean, we could put roots on there underground as well. There. Now then, this tree, let's just pretend that there's leaves on it as well for now. There. So, where is this tree going to grow? Well, it can only grow so far at the top, can't it? Because the branches won't be able to grow where the other tree is. So it's going to probably grow more on the other side. Look like that. And it might try and grow a bit higher because it's got to compete for the light. So that's kind of the boundary of one tree where that one's grown. And then the boundary of this one would be there. And then if you imagine there's more trees growing, if we could, maybe we could think about what it would be like to look from above down on a tree canopy. So if you imagine there was a forest, maybe a tropical rainforest, and you look down on top of it, then, and you tried to identify where one tree ended and another tree started, you'd kind of have little, almost picture like that, wouldn't you? Yeah, where all of the trees formed into a canopy. And they look a bit like cells. What do they look like? When we look at that picture, it looks a bit like C, E, L, L and S. Yeah, it looks a bit like cells. Now then. So, oh yeah, what I missed out the key point here. When the trees grow and a new tree grows, the key point is that a tree will continue to grow. It will continue to grow in directions that are accessible to them. Trees will continue to grow in directions that are accessible to them. So in that case, it couldn't grow that way, but it would grow that way. A bit like plants as well. If you've got a house plant and you've positioned your plant pot up against the wall, it can't grow into the wall, but it will start growing in directions that are accessible. So they grow in directions that are, come on, just for practice, A, C, C, E, S, S, I, after the I, B, and we're just practicing L and E. Yes, they grow in directions that are accessible. Okay, so we drew a little rough picture of what it might look like if you looked down on the trees. Let me show you though that that tree canopies can actually be modelled mathematically using a Voronoi diagram. So we're going to draw a box. And on a Voronoi diagram, I'm going to tell you, all of the cells are represented by straight lines. Here we are. So we'll do a, and we can put the tree, we can put it, mark in the tree trunks as well. So we've got a dot for the tree trunk. You can help me draw them. We're going to do 1, 2, 5. We'll do another one down there. A dot. Good. We'll do another tree trunk here. Another one up here. And another one down there. Okay, very nice. Now I'm going to draw some lines on to make it into a Voronoi diagram. Oh, there, look. There. There. And there. Now, so we've got, I'll just go over that so we can see them a bit sharper. So those are tree trunks, and basically we've just mapped that into a Voronoi diagram. Yes, you can see 1 tree trunk. Go on, count them. 2, 3, 4. On our diagram we've got 1 more. 5. On our diagram we've got how many? Let's write the number 5. Because you're doing so well with your writing today. Let's do it. Let's write the number 5. There. Yeah, you're doing so well. Let's just write it just for practice. It's good. Or we can do it on here. Might be easier if I just held it. Here we are. Let's just practice doing a number 5. 5 is, see if you can remember, down. Oh, I like it. And do the hat on the top. Lovely. Just do another one. You did so well then. We're just practicing. Down. Keep it going around. Oh, you just took the pencil off then. Let's put it back on. Round. And then across on the top. Across on the top. Across on the top. Go on. I'll help you start off. There it is. And then take it across. 5. Very nice. So we've got 5 trees there. And we've made the cells with straight lines. So they're called cells. So that is, each cell represents a tree canopy. And this, the tree trunk on the Voronoi diagram is called a site, S-I-T-E. Okay, now then, the thing about a Voronoi diagram is that any point inside its cell, so that would be the cell, any point inside the cell is equidistant, is closer to the site, that is the tree trunk, in its cell than to the site of any other cell. So we've been reasonably accurate in this diagram. Any point, let's just shade it in. I think that will make it easier to say. We'll shade in one of the cells. Let's get a colour. Here we are. You can help me. Right, if we shade in this one, there, so we're going to do this sort of action, like that. I'll help you because I know it's not that easy, but there we are. We'll shade in just that cell, keeping the lines, there we are, see? Right, and then we'll do another one in a different colour, just so that we can make it easier. There we are, so we've done orange, now we'll do one in blue. So we'll do this one. There we are. And my diagram's not that accurate actually, but it doesn't matter, we can still. There, all the way to the edge. Right, so any point in the orange cell, what do we say, would be closer to the site, that's the dot, okay, in its own cell, than the site in another cell. Do you get that? Any point in the, can you put that into your words? Or just repeat whatever you want to say. A, N, Y, N-E, P, A, R, T, any part. O, yeah, let's just talk about our diagram. Of, T, H, E, very nice. Any part of the, let's talk about the orange cell. Let's just talk about that one. So any part of the, let's do orange cell. O, R, go on. Up for the A, N, yeah, G, you're there, E, orange cell, C-E-L, C, E, L, and L, any part of the orange cell. Right, now you carry it on. Any part of the orange cell, go on. W, I, L, L, will be, E will be, C, that's right, you're right, go on, push, move your arm, move your elbow, C, L, go on, move your arm, C, L, you're there, push, 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 push to the O. It's alright. Let's just swap to this one for now. C, L will be, write that down, any part of the orange cell will be C, L, go on. After the L would be O and S and E and R and T and O and I and T and S and S and I and T and E will be, that's good, will be closer to its site, like the tree trunk, okay? T, H, A, N, than, T, H, E, then the, S, ooh, go on, you're there, push, 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 I, and, go on, S, I, move that elbow, go on, S, I, one over, you're there, T, you go on, we're just getting this all moving, S, I, T, go for the E, it must be E, then the site, take a break, any part of the orange cell will be closer to its site than the site, and I'm going to finish it off for you, of another cell. That's very good. I'll finish that one. Any part of the orange cell, so any part in there is going to be closer to the dot than to another dot there or another dot there. Okay, very good. So, oh, sorry, we're getting a bit cluttered here. Oh, what about a point on the borderline? Let's put a cross on the borderline. So on the border between two cells, let's put a cross there or a little mark. Can you see? That's good, that's good, that's it there. Yeah, if we put a dot there, that would be a borderline. I'll just help. That could be a cross. Find another borderline on the picture. Oh yes, that's a good one, because that's a border of more than one of the cells. We'll put a little cross there. So, what happens if you look at a point that is exactly on the border? Well, if it's exactly on the border, then that point will be equidistant to the sites on the adjoining cells. Equidistant means what? Equidistance would mean, tap tap, would mean T, come on, H, E, V, S, A, very good, M and E. Yeah, equidistant would mean the same, so I'll just label that one. We'll put, if it's on the boundary, it would be equidistant, which means the same. So if you were to measure here, that would be the same to there, that would be the same to there, and that would be the same to there. Okay. That was very nice working there. So that was just an example of using a mathematical diagram to map a tree canopy. But where else might we find Voronoi diagrams? Where will we find them? In nature. If I give you a clue and said bees, can you guess what a Voronoi diagram has to do with a bee? T, H, E, V, the what? The H, O, N, E, H-O-N-E, you're right. You're there, touch it. Not the X, you want the Y, don't you? Use a pencil. Honey, C-O, very nice. C-O, keep it going, lean forward a bit if that helps. I'll hold this a bit lower. M and P, yes, the honeycomb. The honeycomb. Let's have a little think. So a honeycomb is looks a bit like this. I'm going to see if I can just sketch a little bit of it. Look, you've got and then you've got another one. Then you've got another one. Like that. And another one. Look. I wonder if you could help draw one. There. So I'm joining all of these shapes. Oh look. There. They're all the same like that. There. There. So, what shape? What shape is the honeycomb? Or what are those little shapes? Just put the sight inside there. Look, there's a honeycomb. What shape are all those components of the honeycomb? What shape are they? they have, tell you what, we'll count the sides. Come here, you have a look. There we are, we've got 1, 2, 3, 4, 5, 6. 6 sides make a, 6 sides make a H, E, X. Very nice. H, E, X, A. And you're there. G, I'll give you some feedback. Go for it. I'll help you. Go for it. Touch, touch, touch. O, I'll give you feedback when you touch it. And then N. Go on, touch the N. Just to finish it. Go on, touch the N. Hexa. I'll hold it low for you. Chris, come on. Chris, lift, lift. Go on. Touch the N. Hexagon. Yes, 6 sides. They've got 6. There's 6 sides, which is called a hexagon. So you can use a Voronoi diagram, a Voronoi, not Voronoi diagram for a bee's honeycomb. Oh, guess what? Actually, I'm going to call one up on my phone and we'll have a look at the picture. Wait a minute, I'll show you. Even on animals. Let me just Google it. I should have printed one of these out before I came in, but that's okay. So we can look at it on here because you're quite good now looking on here. Let me just do picture of giraffe. Okay. Oh, there we are. Can you see this? Let's just look at it. There. See the picture of the giraffe? Now, when you look at it, look, it's all of the spots on the giraffe are like the cells on a Voronoi diagram. And if you put a little dot in the middle of them to mark the site, all of that mathematical rule would apply. Isn't that amazing? So, we can say you find them in nature, in bees' honeycombs, on what? What creature did we look at? What was the animal name? On G, I, R, A, F. We'll take that as double F. E, S, yes, on giraffes. And even on dragonfly wings. Let's have a look at a dragonfly wing as well. That might be a good thing to look at. Saying, do you want to buy that poster? It's a nice poster actually, isn't it? Let's have a look at dragonfly wings. Let's see if we can see Voronoi diagram. Dragonfly wings. Ooh, we'll have to enlarge it. Oh, I don't know if we can enlarge it enough on that. See how fine they are, and you can see there's little fine lines on them. I wonder if we've got a better picture. Oh, look, people have made jewellery out of them. Dragonfly wing. Oh, here we are. There. See if we can find it on that one. Oh, that's better. Look, there we are. Can you see the way that it's all lots of little straight lines, all joining? It's like a Voronoi diagram. So, do you think there is any practical use for these mathematical diagrams that we might look at them and think, what might this be useful for? And I'm going to give you a clue. It's for kind of planning and kind of town planning. So one use would be for town planning. I wonder if you could think specifically of any use. And if you can't think of it, it's fine. You're feeling a bit tired. You're going to sleep on me, Chris. Do you think you could finish this just quickly and then we'll have a little rest? You're looking very tired. Go on, have a go. Town planning. C A T C H, catch, M, go on, let's just finish it. E, after the E would be, go on, N, and you're doing so well. Catchment, catchment. A, go on, R, after the R, using there, they're used in town planning. Catchment, you're doing so well. A, I'm going to finish it. Catchment areas, for what? An example for what? Catchment area for what? Catchment area for S, C, that's all right, you just heard Dad, S, C, go on, you're doing so well. So we did catchment, I finished it for you, areas for, and you've done S, C, lift your arm, let's finish it off. H, O, O, L, S, catchment areas for schools. Yes, you're right. Do you remember when, oh dear, all the problems we had? People not getting into the schools that they wanted. And that's what the school does really. They have like the site is the part where the school is, and then they have to come up with an area around that site where the children from within that area can go to the school. But actually even that cell changes from year to year because it depends on birth rates. But they use it for other things as well, not just for schools. It's kind of like a catchment area for things like fire stations. If you think about it, you need to make sure that you've got a fire station located so that it can get to all of the places in that area quickly. So when they're deciding where to locate the fire stations, they probably draw out a Voronoi diagram and think, well, we need one here, we need one here, we need one here. So they might take like a map of the country or a map of the location and sketch the catchment areas on top of the map. So that's the sort of the practical uses. But you know what? If we go back to the very point at the beginning of the session, I said Voronoi diagrams, and we use them to represent the trees, and the learning point was that trees continue to grow in directions that are accessible to them. We can take that as a learning point for life. In life, you may hit obstacles, and that's okay. You might not be able to even overcome that obstacle, but you can grow in other ways. And you can keep, I think the key thing is to grow in any direction that is accessible to you. Okay. I think you need to have a little lie down, don't you? Come on, let's have a little lie down. I was going to ask you to write something profound, but I can see that you've got very tired. Come and have a little lie down. You lie down and I'm going to read to you the little bit